Welcome back to another explainer. Today, we are absolutely jumping right into the deep end, literally journeying to the absolute edge of the unknown. We're going to look at some of the most mind-bending, extreme objects in the entire universe. I mean, we're talking about places where gravity is so impossibly intense that absolutely nothing can escape its grasp. It's a place where our current understanding of physics just completely breaks down. Let's get into it.
Okay, let's dive into this. Here is our flight plan so we can break this massive, kind of terrifying concept down step by step. 1. What is a black hole? 2. The birth of a monster. 3. Anatomy of the abyss. 4. 3 sizes of black holes. And finally, 5. How we see the invisible.
So, moving right into section 1, what is a black hole? Let's set the stage here for what these extreme objects actually are.
At its core, a black hole is a region of space with gravity so intense that absolutely nothing escapes. I mean, think about it. We know light is the fastest entity in the universe, right? But even the staggering speed of light is not enough to outrun this sheer gravitational trapdoor. It's the ultimate cosmic dead end.
Which brings us to section 2, the birth of a monster. How does the universe even create something like this?
Well, this monster is actually born from an incredibly explosive sequence. It all starts with massive stars, and we're talking giants here, at least 10 times the mass of our own sun. When these massive stars finally exhaust their fuel, the outward pressure that's been holding them up just vanishes. Poof! In a fraction of a second, gravity completely takes over, collapsing the star inward and triggering a massive supernova explosion. When the cosmic dust finally clears, an incredibly dense core remains. And if that core is heavy enough, well, gravity wins the final battle, collapsing endlessly inward to form a black hole.
All right, moving to section 3, Anatomy of the Abyss. We're going to take a guided tour right up to the edge and straight into the center of the unknown.
And this brilliantly illustrates the singularity. This is the very center where matter is crushed into an infinitely small point of infinite density. Imagine all that massive stellar material packed into a literal microscopic speck. It's the ultimate paradox where general relativity and quantum mechanics violently clash. At this exact infinitely dense point, the known laws of physics simply cease to operate. They just stop.
Now, surrounding that singularity is the event horizon. You can think of this as the absolute point of no return. It's a spherical boundary around the center, representing the exact point where the required escape velocity officially exceeds the speed of light. Once anything, literally anything, crosses this spherical line, making escape impossible, there is zero chance of turning back. It is a one-way door in space, no exceptions.
Okay, so swirling just outside that boundary is the accretion disk. Now, to be clear, while this isn't technically part of the black hole itself, this superheated, fast-spinning material is absolutely crucial to the overall anatomy. It's a massive disk of gas, dust, and even shredded stars spiraling violently toward the event horizon at a fraction of the speed of light. Because all this material is spinning and smashing together at such high speeds, it heats up dramatically, emitting intense X-rays and blinding light right on the very edge of the total darkness.
Shifting gears a bit, Section 4, 3 sizes of black holes. Astronomers actually use a sort of rule of 3 to categorize these giants by their mass.
Let's ground their scale by comparing them to our own sun. First up, we have stellar black holes. These are small but incredibly deadly, packing somewhere between 3 to 20 times the mass of our sun, and they are basically scattered all throughout our galaxy. Then we have the rarer middle children, intermediate black holes. These range from 100 to 100,000 times the sun's mass, sort of bridging the gap to the true giants.
But then, there is this number, 1 billion. I just want to pause for a second and let that completely massive number sink in. Imagine the sheer, mind-boggling size and mass of our sun, and then multiply it by up to 1 billion. It's almost hard to wrap your head around, right? So, the crucial point is, we are talking about supermassive black holes. These absolute monsters are millions, sometimes billions of times more massive than the sun. And here's the crazy part. They aren't just floating randomly out there. They live right at the centers of almost all large galaxies. In fact, we have one right here in our own Milky Way galaxy. It's a giant known as Sagittarius A star, which our entire solar system actually orbits around.
Finally, Section 5, how we see the invisible. We're going to solve the ultimate paradox of observing the unphotographable.
It brings up the ultimate question we have to ask ourselves. If light can't escape them, making them technically invisible, can we actually see them? I mean, how do astronomers possibly find these totally dark voids against the absolute blackness of space?
Now, what's really interesting about this slide is the massive contrast we face. The invisible void versus the highly visible, chaotic effects it has on nearby matter. You see, we don't actually look for the black hole itself. We look for its violent gravitational signature. We search for stars orbiting basically nothing at impossible speeds, or we look for the blazing friction of that accretion disk we talked about earlier. We map the invisible entirely by observing its sheer gravitational dominance over everything nearby.
And you know what? This exact technique led to a monumental breakthrough back in 2019, the Event Horizon Telescope, which, by the way, essentially turned the entire Earth into one giant satellite dish, captured the first ever direct image of a black hole shadow in the galaxy M87. It was an absolute triumph. For the first time, humanity finally proved these cosmic giants are real by capturing its shadow, turning decades of abstract math into stunning visual reality.
But even with these direct images, black holes still hold the ultimate secret. Think about it. If the known laws of physics simply break down at the center, at the singularity, what rules actually take their place? It's a profound, completely mind-bending mystery that leaves us wondering just how much of our universe we have yet to truly understand. Thank you so much for joining me on this explainer, and keep exploring the unknown.